Okay, our works consists a study on the effects of parameters of fused filament fabrication on the tensile strength of hybrid PLA wood parts. This is the brief outline of our work, introduction, experimental setup, our result, a statistical analysis of our results, and finally, conclusions and future perspectives. It's well known that additive manufacturing is a well-promising non-conventional manufacturing process that utilize metallic, plastic, ceramics, and composite materials. Among the so-called additive manufacturing processes, fused filament fabrications, also referred as fusion deposition modeling, is one of the most popular processes, since due to its simplicity and also due to a range of materials available in the market. We have two objectives in our work. First, to experimentally investigate the effect of process parameter on the ultimate tensile strength of composite parts, and second, a predictive modeling for ultimate tensile strength by examining statistical results for our experiments. This predictive modeling is a first step to our research, since we are planning to also apply to soft computing techniques such as neural network and genetic algorithms. Here you can see the proposed experimental approach. We designed a mixed level Taguchi plan. We have four. Yes, please. We have four main process parameters: layer thickness, nozzle temperature, raster deposition angle, and the painting speed, and 2 or 3 levels for each parameter. Therefore, we have a mixed level Taguchi design of experiment. This design involved 18 experiments, and it has the advantage to study the effect of 4 factors and their interaction on the response. Some details about the physics and the meaning of parameter. Due to restriction of time, I will not speak about them. Layer thickness, nozzle temperature, raster deposition angle, and painting speeds, well known to scientists. This is just some illustrations of the experimental procedure. Here you can see a schematic diagram of FDM process. Here is a graph of a resulting specimen with a gap and raster angle, and then just some words about the material. The materials is a commercially available wood plus 30% coconut PLA with 30% coconut fiber. The filament diameter was 1.75 millimeters, and for each specimen, load extension and stress strain curves were obtained. Just a the dog bone specimen here with the dimension according to ISTM specifications and the process of printing this specimen. In the next slide, you can see the realization of experiments, the samples before the experiment, the stressing, the specimens after the test. It's the icons indicate clearly a brittle type fracture and some representative stress strain curves. Here we have an overview of the experimental results. 18 specimens according to mixed design, to mixed Zaoutsos design, the corresponding parameters and the objective, the UTS. Based on these experimental results, we proceed on a statistical analysis and regression modeling of these results. We applied ANOVA in order to examine the effects of these parameters on the output, on the UTS. We used a full quadratic regression model for fitting the data.
Professor
This model allows us to stand.
You have 2 minutes, sorry to interrupt you, but you have 2 minutes if you can go on with the conclusion.
Yes, I know. I checked my time. Thank you. As I said, we applied full quadratic model. By applying Anderson dialing test, it was verified that this model was suitable. You can see here a very good agreement between experimental and theoretical results. Then we proceed to examine the response surface based on the response surface methodology. We proceeded to examine the interaction effect. You can see just indicative the interaction effect. To start with, dark Greek regions in the contour plots indicate advantage results for maximizing UTS. You can see in these slides the interaction effect among lower thickness and nozzle temperature. I will take it very in brief. Here, the interaction between layer thickness and deposition angle. Similarly, the interaction effect among the lower thickness and printing speeds. That I think I have 1 minute. I am going to conclusions. It was found that FDM parameters strongly affect the response, that is to say, the UTS. Regression modeling was used successfully for generating prediction, that is to say, quadratic model and response surfaces. You can see that coefficient of correlation is high. And as a future perspective, this model will be used as objective function for genetic algorithms to optimize the FDM operation, not only for PLA composite material and for other materials. I understand that this presentation was very brief due to time restrictions. Full presentations of results will be presented in the paper in the procedure, we hope. You can see just acknowledgement, and thank you for your patience and your attention. I am at your disposal.